You're listening to the Patenting for Inventors podcast, part of the Look Legal Pods from the law firm of Nolan Hyman, the #1 source for your intellectual property, business, and entertainment law needs. Now here's your host, registered patent attorney, Adam Diament.
Hello and welcome to the Patenting for Inventors podcast. I'm your host, Adam Diament, a registered patent attorney and partner at the law firm of Nolan Hyman in Los Angeles, California. This episode is How to Patent an Algorithm Without Saying Algorithm. So this one's kind of a funny topic because I get this question, or at least some version of it, all the time. Someone comes to me and says, hey, I've got this awesome algorithm that can do XYZ. Can I patent it? And I usually say something like, maybe, but we're not going to call it an algorithm, at least not in the patent claims. And that's when I get the raised eyebrow. Now look, when you hear the word algorithm, you're probably thinking a set of instructions, a step-by-step way to solve a problem or do something, right? Like a recipe. That's basically what it is. But in the world of patent law, the word algorithm raises all kinds of red flags. The reason is because of how patent eligibility works, especially under the code that is known as 35 U.S.C. 101, the bane of every patent attorney's existence. See, under Section 101, there are certain categories of things that you can't patent, no matter how cool or useful they are. One of those is abstract ideas. And guess what gets tossed into the abstract idea bucket all the time? That's right, algorithms. Courts have basically said you can't patent a math formula. You can't patent a basic calculation or logical operation. Those are the building blocks of innovation. And they have to stay free for everyone to use. So does that mean that you can't patent an algorithm? Well, not exactly. You just have to be really careful about how you frame it. And that's where we come in, people like me, because patent attorneys have gotten very good at dancing around the word algorithm without actually saying it. Let's say you've developed some clever routine for processing images faster, or a method for making financial predictions using historical data. On its face, those things might look like pure math or logic. But if you implement them in a very specific technical way, and you describe the real-world problems they solve, suddenly we're not talking about just an algorithm anymore. We're talking about a process, a method, a system, and those things you can patent. The trick is to anchor your idea to something concrete, like, is your method being performed on a computer? Is it tied to some kind of hardware or network structure? Does it result in transformation of data that produces a useful, tangible result? These are the kinds of questions we ask to see if your invention can survive a Section 101 challenge. Now, here's where the language starts to matter a lot. Instead of saying, my invention is an algorithm for doing X, we might say something like, a computer-implemented method comprising receiving input data, processing that data using a set of weighted parameters, and generating an output signal based on a threshold comparison. Is that just a dressed-up way of saying algorithm? Kind of, but it's doing so in a way that maps it to real-world applications, and that's what makes it eligible. And honestly, this is where things get a little artful, because you want to describe what your invention does, not just what it is. If you say it's an algorithm, that's like saying it's just logic, and that's a big no-no. But if you describe how that logic gets used, how it interacts with hardware, how it produces results, how it improves performance, now you're giving the examiner something to latch onto. I'll give you an example. Let's say you've come up with a new way for a self-driving car to decide when to slow down at a yellow light. It uses speed, distance, traffic patterns, and a few other variables. Now, if you just file a patent application saying, I've got an algorithm that takes these variables and spits out a decision, you're probably going to get rejected. But if you say, a computer system in a vehicle configured to receive sensor data, apply a decision-making process based on time to intersection and traffic flow, and output a brake signal, now we're talking about a computer-implemented method with a tangible output. That's patentable territory. Same thing goes for stuff like recommendation engines. Think Netflix, Amazon, dating apps. Sure, they're using algorithm, but in the patent world, you'd frame it as a method for presenting personalized content to a user based on historical interaction data, comprising, and then you go into all the steps. And the thing is, you don't even have to use the word algorithm anywhere in the application. In fact, it's usually better if you don't. You talk about rules, instructions, processes, decision trees, parameter sets, trained models, and all sorts of other friendly sounding phrases. It's all code for algorithm, but it sounds a lot less abstract, and that's the goal. Now, there's one more thing that trips people up, and that's the idea of math. People think, well, my invention uses math. Math isn't patentable, right? And again, it depends. Pure math? No. But applied math, That's part of a larger system that produces a practical result. That's a different story. If your equations are buried inside a method that, say, improves the speed of a video encoder or optimizes bandwidth usage, you've got something to work from. So let's say you've got this invention that is really math heavy. You've got formulas, you've got matrices, maybe you even got machine learning models that weights and biases flying around. You might think, there's no way this is getting past the patent office. But here's the secret sauce. The patent office isn't interested in math as a concept. They're interested in whether your math does something. Like, does it improve computer functionality? Does it make something run faster, smoother, better? If the answer is yes, then you're not just talking about an abstract algorithm. You're talking about a method of improving a computer system, and that's a big distinction. One of the phrases we'll often use is something like improving the operation of a computer itself. It sounds a little buzzwordy, but trust me, examiners love that stuff because it signals that your invention isn't just theory, it's implementation. And the other trick is to wrap it up in technical language. Like, instead of saying, my system analyzes data, say something like, the system receives time series telemetry data from a plurality of sensors, performs pre-processing via a convolution filter bank, and outputs a prediction signal indicative of fault conditions. See, we just went from algorithm to diagnostic system, and nobody blinked. Now, if you're using artificial intelligence or machine learning, you're probably thinking, wait, aren't those just a bunch of algorithms? Yeah, they are, but again, we don't lead with that. We talk about how the system is trained, what inputs it uses, what the output means, and this is key, what real-world problem it solves. Like, does your model reduce fraud in online transactions, improve voice recognition in noisy environments, predict equipment failure before it happens? That's the meat. A lot of this comes down to storytelling. You're painting a picture of your invention, not as a formula in a vacuum, but as part of a working machine. It's like describing a blender. You wouldn't say, it uses torque and rotational acceleration algorithms. You'd say, it blends smoothies faster and more evenly. Same idea, function over formula. And while we're on the subject, let's talk about claims. That's the part of the patent where you say, here's what I want exclusive rights to. And you have to be really deliberate about how you write those. You can't just say, I claim an algorithm that calculates optimal routes. That's going to get shot down. But if you claim a method comprising receiving GPS coordinates, retrieving traffic data, applying a weighting function based on user-defined preferences, and generating a turn-by-turn navigation path, now you've got something concrete, something that sounds like a real-world system, not a whiteboard doodle. Honestly, I get that this feels like word games, it kind of is, but that's the dance we do in patent law. We take something abstract and wrap it with enough specificity and technical language to show that it's not just an idea, it's an invention. You might also be wondering, okay, but what about software patents? Aren't those getting harder to get? And yeah, they are. The bar has definitely been raised over the years, especially after some big Supreme Court decisions, but they're not impossible. In fact, software patents are still issued every single day. The difference is that now you've got to show that your invention isn't just doing something people are already doing mentally just faster. You've got to show there's some kind of technical advance. And no, you don't have to build the whole thing before you file. You don't need a working prototype. You just have to describe it well enough that someone skilled in the field could reasonably put it together. That's why it's super helpful to work with a patent attorney who knows how to take your invention, even if it's just a concept right now, and dress it up with all the right language, all the right flowcharts, and all the right technical goodies. Now, if you're tempted to drop the word algorithm into your patent application, just resist the urge. Think of it like going to a job interview and saying, I'm kind of lazy but very efficient. That might be true, but that's not exactly how you want to present yourself. Same with algorithms. We all know they're there. You just don't need to shine a spotlight on them. And should I say, not every patent examiner is going to ding you for just saying algorithm, but some will. And the ones that do can really drag out the process. So why take the chance? If you can just talk some inputs, outputs, and the steps in between, and show how those steps are tied to a useful result, you're way better off. All right, let me wrap this up with a quick recap without actually calling it a recap, because this is a podcast, not a PowerPoint. Basically, you've got something cool that feels like an algorithm. Don't panic. Patent law doesn't ban logic or steps or instructions. It just doesn't want to give you a monopoly on math in the abstract. So the game is to take that math and show how it's being used in a system, in a method, in a way that solves real-world problems. Do that, and you're in pretty good shape. And if you're still not sure what you've got is patentable, or you just need help putting it all in the right legal language, that's what I'm here for. Seriously, don't go it alone for this one. A small change in how you describe something can be the difference between an allowed patent and a rejection-stamped abstract idea, and nobody wants that. That's it for today's episode. I'm Adam Diament, and if you need help filing a patent application or other intellectual property, give me a call at 424-281-0162. Until next time, I'm Adam Diament, and keep on inventing.
Thanks for listening to the Patenting for Inventors podcast. If you enjoyed the show, please kindly rate and review on your favorite podcast platform. The contents of this podcast are intended for general informational purposes only. The facts of every legal matter are unique, and the content of this podcast should not be construed as offering legal advice for your specific legal situation. For more information about how we can help with your own legal needs, check out our services at nolanhyman.com. That's NOLANHEIMANN.com. Or call Adam Diament directly at 424-281-0162. The preceding information may be considered an attorney advertisement and does not establish any attorney-client relationship.